Hi, I would like to talk to you about our project by us, the Dream Team. Our idea was to create a Bluetooth controlled car that is used to search and discover certain areas, and added to that it had an extra feature that would detect mines, acting as a minesweeping car. It would also have a camera attached to it that had the feature of recording in night vision mode, and it would send the live video, audio, digital signal to the user so he could see where the car is moving.
Hi, I'm Ahmed Ehab. I will be talking about the car assembly. Firstly, we bought this car, but it was small pieces. We firstly gathered it just for the case of testing. Then after that, we tried to assemble it in order to pass all the wires and everything. It has two main wheels and two motors, and the front wheel just for the direction. Also, we put the breadboard in the bottom level, and above that is the edge bridge and the Arduino and the camera. The Bluetooth module is down there, and here we have our sensor. And the final part is the LED, which works through the sensor. This is the camera that we used in our project. We firstly wanted to use a camera that's controlled through the Bluetooth module, but we didn't find anything convenient to us because the transfer rate in the other one controlled by the Bluetooth was so slow and so bad, and also it was so expensive. This camera has both day and night vision. It also has its own sending and transferring module. So this part is connected to the laptop, and it's adjusted in order to get the best audio and video through the tuning. This camera is then connected to a battery that is supposed to be installed in here.
Hi, my name is Moustafa Nagaty, and I was responsible for the connections of the edge bridge and the metal detector. For the edge bridge, we took in 3 inputs from the Arduino, which were the pulse width modulation and moving it forward and moving it backward. And we sent out those commands to the motor, to the right motor and to the left motor. If we take a look at the connections here, these 3 wires are the pulse width modulation and the moving forward and moving backward for the right motor, and the other 3 are for the left motor. Then these values are sent to the motors using these wires, which move it forward and backward for the right motor, and these 2 wires for the left motor. And finally, connected to the edge bridge is the positive VCC, which is this wire, as well as the negative, along with the common ground. For the metal detector, it was connected to via 3 wires, a positive, a negative, and the digital input, which is sent to the Arduino whenever a metal is detected. And we check on this value. Whenever it is 1, we send an output to this LED so that it can light up and indicate to the user that a metal has been detected.
Hi, I'm Ahmed Anwar, and I was responsible for the Bluetooth module connections in the project. First, we used the JY-MCU HC05 Bluetooth module, which had 4 pins. The first pin was the VCC, and it was connected to the output 5 volt from the Arduino board. The second was the ground, and it was connected to the common ground in the breadboard. And the third and fourth pins were the transmit and receive. The transmit pin was connected to the receive pin in the Arduino board, whereas the receive pin was connected to the transmit pin in the Arduino board. We used an Android smartphone to control the Arduino through the Bluetooth module. The application on the Android smartphone send certain commands to control the motor of the car. For example, if the application sent the first command, which is 1, the car will move forward. If it sent 2, it will move backward, and so on.
Hello, I'm Osama. I'll be talking about the code that we use to run the project. So, first thing, we have two motors, so we initialize motor A and motor B. Motor A enable, which is the pulse width modulator, and it's in pin number 9 on the Arduino. Motor A reverse and motor A forward is responsible for moving the wheel either forward or backward, and on pin 8 and 7 in the Arduino. Same thing for motor B, enable pulse width modulator and reverse and forward in pin 6, 4 and 5 on the Arduino. And we initialize the data that we get from the Android application, and initially it's 0. RX pin and TX pin, the receive pin and the transmit, which is of the Bluetooth, and we initialize also the whole pin and the left pin. The whole pin is the mine sensor that we are using. And globally we initialize whole state that we will use later. We'll begin with the setup method. First thing, we want to initialize the inputs and the outputs of our components. So we will begin with the red pin, and it's of course output, the whole pin input, the RX, the receive, is input, and the transmit will of course be output. The motor enable and forward and reverse for both motors will be outputs. Getting down to the loop, which we run our project on. First thing, the whole state is reading the whole pin. The sensor is reading, and we check. If the whole state is high, so we will turn on the LED pin, the LED. Else, it will be turned off. Then we will check the data sent by the mobile application, the data equals serial.read, and we will switch on it. If I send 0, so the motor initially is stopping. Case 1, we have motor A, which is the right wheel, and motor B, which is the left wheel. So in case we write in the terminal in the Android application 1, we want the car to move forward. So motor A and B enable will be 255 or any other value. This is the pulse width, and 255 is the max. So motor forward A and B will be high and reverse will be low. Then we set them to zeros so as to stop after a little bit of moving. If we wrote 2, so we want it to reverse, and it's the same idea as the forward. If we wanted to move left, so we type 3. So the motor B enable would be 0 and A would be any value. Motor A reverse will be low, and motor A forward will be high so as to turn left. Case 4, forward right, it's the same idea as forward left, but here we motor A enable will be 0. Case 5 is reverse left, so motor A enable will be 255, motor B will be 0. Motor A reverse will be high, of course, so as to move backward. And case 6 to reverse right, and it's the same idea as reverse left.
Okay, now I'm controlling the car via the mobile phone. I'm moving forward with the camera and backward. Okay, now I'm controlling the car via the mobile phone. I'm moving forward with the camera and backward. Now I'm controlling the car via the smartphone. and watching the live feed on the laptop. Now I'm controlling the car via the smartphone and watching the live feed on the laptop.